Okay, so checking the fuses out on this. Swap the fuses, or the fuse, and blew again. So I'm thinking, okay, what's on the circuit opposite? And it goes to this 12 volt DC, 250 volt AC, 5 amp relay. This puppy, let's get a zoom in on that. Oh, there we go. So I just ordered 5 of those, and it's shaking. Something's loose in there. So I'm thinking that's fried. Everything else, when I looked, the capacitors seem to be okay. I didn't notice anything in the diodes. I didn't notice anything in the resistors. But it does have a little, let's get a zoom. It's kind of like a copper color on that resistor. So I probably should check that. The low voltage side of the board, I did check all the resistors. I didn't in circuit with an LCR meter, because I don't really have the best one for in-circuit testing. Test all the capacitors. I did test all the resistors. They all look pretty good except one, and then I need to verify the 4-letter designation SMD resistors. Right there, it's supposed to be 53 something, but it's showing 12 something. I don't know these 4-letter ones. I didn't verify. All the other ones looked correct. Don't notice anything burn out. I sure hope this side is that the diodes seem correct. So order the relay, get the new relay. Makes sense that burnt. I don't hear any shaking with the big relay, so I'm guessing that's not really going to be an issue. But that's a 12 volt DC 20 amp. But I'm not 100% sure. I'm guessing that triggered, and then that's why the fuse burnt, because something was funky with this relay on this side, which goes to the compressor. What would that be? Like a fuse relay, and the fan. New fan shouldn't be the issue. So let's check out and see what's up with the compressor. And I took this cover off. There's just 2 leads going into here, and I pulled out the 2 little components that were there. I think it's a relay and a isolation, or I forget what they call it. It's like a fuse, if I understand correctly. I didn't check to see power coming out here, but what I did was, and then I could verify powers coming into this, and then check, which I did check this side, which is that there's continuity with all the plugs, the three plugs, checking the different configurations, making sure it's continuity. Also checking each of the plugs to being shorted out to ground, which wasn't. So that was good. So I figured the compressor's good. Makes sense though, it seemed like that was working fine. The only issue was the fan. And then when I was fiddling around trying to measure these values, I think I slipped, and that's where you can see the little burn mark. So I'm thinking when I was touching with the probe, kind of had a spark flash moment. I'm not remember exactly what I did. I think when I was on ground, I don't know, I did something wrong though. Whatever I did it wrong. And that's what triggered this whole mess of frying the fuse and the relay, I'm guessing. Hopefully it's all educated guess. And I'm thinking everything else should work, because prior to that, everything was working except the fan. Now I've got this other Whirlpool Gold Star that I picked up for $38, actually $40 with some other components. These little, what are these, digital to analog converter. I thought it'd be kind of cool for like $2.99, two of them, and it has the fiber optic S-Diff or SP-Diff, whatever it's called. So I figured I'd, with that Bose, I think it's a Bose or an Alpine CD changer, the SP-Diff, and then the analog phone jack, to see about hacking. If I don't, I might just sell those, the Mercedes S-Class DAC, subwoofer, amplifier, and CD changer I got for like $4.99 each at the Goodwill. And I was thinking I was going to scrap them out. I was thinking put them in the truck. And then I'm kind of like, I don't know, I have a better DAC actually. But I like that multi-change CD player, and I like the subwoofer and the amplifier. Actually, I paid a little more for that. That I bought on eBay for like $80, I think. But I was thinking I could sell the DAC and the CD changer, just maybe even the DAC alone. That's a whole other kind of tangent. So since that other, the Whirlpool dehumidifier wasn't working, that one the fan's working, but the fan's not the right size for this. So I didn't want to risk it, so I figured for $40 I'll order another fan, because I friggin' tell that was working okay other than the fan. And that definitely burnt out. I mean, this, you can see it's pretty bad shape. If you can really, if you notice anything, main thing here were the bearings, and those, I think it must have got where the whatever was in there, packing material, grease, looked almost like a spongy material, burnt up and started wobbling, and can see where ground in literally to the bearing, I forget what you call it, cup or seat. And that wound up overheating, melted some the plastic on the top, so it sunk a little bit. It's not in the way of the fan. Probably could take a heat gun to that and push that back up. I did it. I figured for now I wanted to, because I thought at least with the new fuse I'd get this going. I didn't really shake or test the relay in detail, but now after I blew the other fuse, kind of working down the circuit, what would have done that? First thing, it looks bad for sure. Of everything that I tested, it doesn't seem bad. Transformer seemed okay. Everything seems alright, not powered on at least. Looks like the relay is definitely, I think if I, that's, what's that? Hear it. Something's not right in there, so got a couple more fuses left. So, yeah, 4 more and 5 relays on the way, and swap those back in and see if dehumidifier working again. This has a good LG. I think this is the looks like Zenith makes one. This is a Kenmore version. Looks like there's a Zenith equivalent. There's a Kenmore equivalent. This is just like the analog dials, 2-speed fan. It looks like there might be also a Whirlpool and similar, that's a digital display. Though I think this one's easier to work on. And the other one I have is a Gold Star Whirlpool with a, what is this? This is an 8070 USS. This one is going to have to have a compressor checked before I ran it. The compressor seemed warm for sure. So I need to look more. I'm guessing this is going to be a refrigerant issue more, but there could be something else going on with this not working with either the evaporator or the condenser. I think I was saying condenser before, but I think it's evaporators on the outside. This looks kind of corroded. You know, so we can probably take this apart. See in here, real quick, maybe I can just show how I did with the other one. Everything's unplugged. This is some kind of Ritchie, so it looks like it's newer, cheapo system. It's a little different design. Looks like it has some kind of starter on the outside or whatever that is. This is a little different than what I've seen before to test. So, let's see what I can't just get in there and do that on camera. What I'm going to do is see if the compressor motor is an issue. Then I'll test also and see if this one, the motor is not an issue. Motor and fan's working fine. It's just we're not getting enough cooling. I noticed there's cooling on one little line. I think it must have been going into the evaporator. So this one hopefully is not a refrigeration issue where the evaporator is, I don't know, maybe I could take it apart and try to clean it a little better and see if that's the issue. Or maybe the evaporator needs to be cleaned, the condenser needs to be cleaned more. So this is a little different than what I've read about. Definitely has the two connectors. And these ones this is a different type compressor. So let's see, this is that little fuse isolations. Looks like a fuse. Alright, let's see if I can get this off. Try to remember those wires, what's going where. And what you do is, there's these three connectors in there. What you're going to do is check for continuity. And if continuity, you want to check for each one also. So it looks good. Continuity in all of them. Have the beep, I'll get like 0.005, 001 on that one. Okay, hopefully there's nothing. And then you want to check also with each one, make sure there's not to ground. So no continuity. So I'm guessing the compressor's good on this. 005. And that's not the issue. So put this back together and feeling deeper, but maybe it's just a little higher for some reason. I'll just put that back together and try to figure out where in the circuit, because I'm guessing the issue is, well, not really electrical as much as what I notice in the refrigeration lines, corrosion. And supposedly this one was working when it was sold to me. He said he had removed water from it, so I don't know if somehow sitting in the car, is it laid on the side or something like that, if they did lay it on its back, would that have caused something? And I don't know. But the gentleman was really nice to, I think it's Comeback Power 101, to refund me. It was like $35. So it was like I paid pretty much for the a Loran. I don't think that's working. I have to look into that too. I was thinking maybe I could take out maybe some of the super heterodyne ones. Plus there's a power supply I was supposed to pick up. He had an industrial power supply, and he didn't have that when I got there. So it's kind of nice of him too to do that. But this looks pretty good, other than get in here and look at this evaporator or condenser. Let's call it a condenser. I think it's evaporator to be correct. Oh wait, this is probably screwed. I did clean the filter just to make sure. So what struck me was pretty gross is this here. And I'll zoom into that, get a better look. And compared to the other, pretty clean. That's an older one too. Kenmore, now the Whirlpool. That's pretty green. Let's zoom right in closer. It's pretty gross. And this little spot right here, that line coming over into a circle. Wait, no. Yeah, that line right there. And you can see where it's a little more oxidation. That's the only one that was really cooling, getting cold. So the rest wasn't getting cold. So I'm wondering if something internally is the issue, or and I'm not sure what that zip tie is there for. I guess maybe just to keep that together. I guess it's better to be together. So that's what I need to learn still more, is the heating and cooling side of things. But that front, I guess the front's an evaporator. I was thinking it was a condenser at first, but it might be a evaporator. That's looking pretty rough. So if that's like that on the inside, that's not good. So something could be backing it up. And I don't really see it being too dirty. Looks pretty clean. It is dented a little bit down below, but that's just a little bit, not much. This doesn't look too dirty. So I don't know if airflow, I can brush it though, it might straighten out. Run a little more, but oh, that's the other one I'm going to work on, see what I can do to get that going, because it looks like to me, this has got some kind of reishi, I don't know if it's a cheaper compressor, refrigerator compressor. This is a 70, 70 liter model versus this other one that's the 30, I say liter, 70 pints per 24 hours, and the Kenmore's seems to be more reliable, at least was a 30 pints per hour. So this big one, I'm hoping I can get that going too. And like I said, I don't think it's an electronics issue. I'm thinking it's something to do with the refrigeration. It's getting me like with it. Central air here I'm supposed to work it out. This is kind of like jumping me into learning, like I was trying to learn electronics with electronics equipment. I'm used to like spectrometers, but more like oscilloscopes and other kind of spectrum analyzers outside of just the chemistry and biochemistry and microbiology and metallurgy and polymer science world. Get into more of the radio frequency engineering, radiological world. Maybe I'm going to have a little jump into the heating and cooling. And I'm already familiar with ventilation. A little bit more with heating than I am with cooling. So refrigeration really, I guess, would probably be the better term. Learning some of the details of refrigeration. So like say with my truck even, where that AC compressor, I guess when I had checked last for leakage, there's no leakage. That happened to be an electromagnetic clutch I need to swap out. And still have that in the floorboard. I just haven't done that yet. Because I have a bunch of other projects like with the body to work on and cap to work on. I think I want to retrofit the cap before I tore everything apart, kind of play around with it, get a feel how it's going to be. Because I figure once I do the body, I'm going to be pulling the bed off, the cab off, or at least the laziest would be jacking the cab up a little ways, taking apart a lot of what I can at least. Pretty much everything to sandblast and check the metal integrity, treat it, and then weld in new metal and the new panels. Treat again, blast, treat, prime, paint, and then undercoat, clear coat, undercoat, seal that up real well. Seems like it might not be a bad thing to learn. And I'm thinking too, the refrigeration, especially not sweating, not having sweat glands, might not be a bad idea to learn some of this refrigeration stuff. Because cooling towers are super simple, swamp coolers are super simple, evaporative cooling is very simple. So that's really easy to learn and really easy to apply. I know that stuff, I can make a lot of stuff myself from scratch. Now when it comes to the refrigerant world with the compressors and the condensing and evaporating and kind of understand pressurizing through an orifice and then the phase change under certain standard temperature, or just temperature and pressures, there's the different effects of heat with the properties of whatever that medium is, so the refrigerant, to get the effect where you want to transfer the heat more effectively to a point where you're cooling or even freezing, depending on what side of the, I guess it'd be a differential you're in. So try to figure this out next. Meantime, I have to wait for relays, which is kind of funny. I almost want to open this up and just see if there's a relay in there. I think I could salvage for the relay. It's kind of funny with the AX850 power supplies. I picked up 2 for $29.95. I thought they were a great deal because they're like Pro, Corsair, supposed to be these highly rated power supplies. Well, I think somebody made a note that the transformers, filter transformers get loose, need to be resoldered. It's like a known issue with these, and I didn't see that. What I saw on this one, did I have that? This one I saw that, and this has really high quality components. So I figured for $29.95 I can salvage components off this for radio work and power supply work. So I mean they're all 16 volts. Like in there 470, 330. They're all like polymer caps. They look like really good quality ones. And quality brands too. So I'm thinking, well, if anything, I'll just salvage components. And I figured, well, I'm going to try first repairing. And so I swapped. I had a video card, Michigan State University surplus supply store, desoldered inductor off here, and then the 470 microfarad 16 volt cap, resoldered it to replace this one that was blown up. Definitely burnt. Zoom in. There it is. Burnt spot. Well, I resoldered this one in, and then I've got testing. I only have 2 pins. One's 3.13 volt and the other's 5 volt. Figures the 5 volts the one where they Corsair online suggests how to test these. That works. And so the external fan I hooked up was working, but the internal fan was not working. So I've got 2 rails working on this, only to those 2 pins. So I'm not sure how many. I have to really. I don't have a schematic for this, so I don't really know exactly what's going on. I need to look into more detail. There might be more caps or more blown. The other one had the fuse blown, and I swapped that out, and it blew. I mean, that just poof, sparked. So there's something more going on with that one. And I was thinking between the 2 I could swap components also, which I can do. I just figured I had those dollar video cards I picked up mostly for the heat sinks, because there are some passive heat sinks, and then there's I think 2 of them, maybe 1. I know 1 for sure that's aluminum, higher quality with a fan heat sink. So I wanted those more for the software-defined radio or other projects. Seems like those cheap ones especially need to be cooled. Even the Hack RF doesn't hurt to have that cooled more. And then for other projects too, to have more passive heat sinks. I don't think that would hurt. And again, salvage usually a decent quality electronics, just the better quality cards, components, so that I could, salvage. I got a little inductor, took off, and practice desoldering and soldering too. This is like a Rubicon. This is another option for look at the zoom. 16 volt 470. This one's a little larger, so I didn't use it for that other power supply. So the A58 is showed. I don't know. Anyways, that's pretty much where I'm at right now. I kind of want to get back to the TDS 520s, TDS 520, TDS 540. Because those are 2 TDSs I still need to work on. And I've the 475A and that B&K Precision 1522. I suppose I need to test those a little more. And then I haven't unboxed one of the TDS 8000s. Oh, and I have the TDS 8000B that's pretty much definitely a power supply issue, but could be going back to the motherboard. And then the latest, the 7904, and it definitely could be modules I'm going to have to work on, because I bought some of those just to have the components, and 1 out of 4 working didn't seem like a bad idea, and I'm hoping more than 1 out of 4 is working. They're not misleading or something happened, I guess, during transport. But figure I better do these simple projects first, practice simple consumer devices, play around with those for a bit, make sure I'm confident with my desoldering skills and soldering skills, and I try and use better components. When I worked on the UPS, the 2000 volts AC, to have that 24 volts battery access to where I could either input, and I never did get to that, but I did get to where I put 2 double pole, double throw switches with 3 positions, so you have one way, middle, and then the other way, so that you can't really mess up the switching to switch between 12 volts or 24 volts internal battery access, so that if I had, say, that in the car for an external power supply, or technically like an inverter too, that I could charge the 12 volts through the banana terminals that I added the 4 in the front. So basically that can also output or input, if you have the charger, 12 volts, and that could charge either with plugging into an outlet. Of course, you're going to want to do that with the switch to the 24 volt configuration, or through the car charger, 12 volts in the 12 volt configuration, or output 12 volts, basically just tapping from the battery. The 12 volts just tapping from the battery directly. And I was wanting to, I just didn't get to that, have input terminals, and I probably need more switches to be safer. And of course higher currents and fuses I added too, to have external sealed lead acid or gel or whatever the battery is input. The only thing was, and it could be solar input too. It's technically I could charge a 12 volt solar too if we've got the right charge controller, or wind. The thing is, with those batteries, external battery inputs, I needed to look into more that automatic charging components. If I'm plugged into 120 running the UPS and there's the external battery switch configuration, how's that going to affect operation? So I needed something where, I didn't want to pair up the internals with the external to run 24 volts. I really needed like another switch in there configuration to cut the access to those 12 volt batteries, either in 12 volts or 24 volt configuration. Just run off the externals, and then running off the externals, is there any issues I need to consider, like diodes so they don't charge when plugged into 120, or maybe there isn't an issue, maybe it's just fuses, so that I just need to upgrade, beef up the current capability, handling capabilities also of the inverter, charger, UPS type internal components. I think I was thinking about fan in there too, just to be safe. So if that's pulling more current, something current limiting, to not overheat, cause fire risk damage. Things I still need to learn a little more in detail. So for now, just like for like, not really modifying. Closest thing to modifying is the fan here, the same model number other than the last letter. And I did notice the fan's 1.7 amp versus the original is, the new one's 1.7 amp, or the original is 1.1. So I'm hoping that's not what's causing the issue. Because that could be, but I don't see components on here that aren't able to handle that. I don't see where there'd be an issue, because it's like pretty much looks like, at least to me, the power coming in comes from the relay, and one of those switched lines goes straight to the fuse and comes over to the other relay that is switched by the 12 volt transformer, the logic over here. So I don't see what, okay, this is switching it right here. It switches to here. I don't see what, and this is either for